Welcome to episode 81 of Paper Brief, where we dive into the latest in machine learning papers. I'm Charlie, your host, and with me today is Cleo, our expert on all things tech and ML. Today we're talking about an exciting paper, DiffiT, Diffusion Vision Transformers for Image Generation. Cleo, can you kick us off by explaining the significance of diffusion models in generative learning?
Absolutely, Charlie. Diffusion models have truly transformed generative learning, enabling the creation of complex, high-fidelity scenes. They work by iteratively denoising Gaussian noise towards realistic images, and at the core there's this denoising autoencoder network shared across the process. It's quite a fascinating area that continues to evolve rapidly.
And how does DiffiT make a mark in this field? What's new with this model?
DiffiT stands out by proposing a novel architecture specifically aimed at making the self-attention layers in the network time-dependent. This means it can adapt more dynamically during the denoising stages, leading to, believe it or not, state-of-the-art results in terms of image generation quality.
That does sound impressive. Can you tell us a bit more about these time-dependent self-attention layers? How exactly do they improve the model?
Sure thing. In standard models, the convolutional filters aren't time-dependent and offer a rather simple view of the temporal aspect. But with DiffiT's time-dependent self-attention, the key, query, and value weights in the layers can be adapted for each time step. This means the model can prioritize different image features at different times, which is crucial for the nuances of high-resolution image generation.
It seems like DiffiT is bridging some gaps in the generative learning scene. But how does it perform in practice?
DiffiT doesn't just talk the talk, it walks the walk. It has achieved new state-of-the-art performance for various class-conditional and unconditional image generation tasks, boasting an FID score of 1.73 on ImageNet 256. That's a pretty big leap forward.
Wow, an FID score of 1.73 is no small feat indeed. What datasets were used to benchmark DiffiT's performance?
The team behind DiffiT tested it on several datasets, including CFAR10 and FFHQ64 for image space, as well as ImageNet 256 and ImageNet 512 for latent space generation. For each of these datasets, DiffiT delivered remarkable performance that sets a new bar for what's achievable.
And for our ML enthusiasts listening, what would you highlight as the biggest takeaway from the DiffiT paper?
I think it's the fact that architecture really matters in generative models. DiffiT is a prime example of how targeted design choices, like time-dependent attention, can significantly improve performance. It's an exciting direction for anyone in the field.
Thanks for unpacking that for us, Cleo. Before we wrap up, where can our listeners find more information about this model?
The team has made their work accessible on GitHub, and I highly recommend checking it out if you're interested in the technical nitty-gritty or even reproducing their experiments.
Fantastic. That's a wrap for today's episode. Be sure to tune into Paper Brief for more insights on cutting-edge ML papers. Thanks for being with us, Cleo, and thank you all for listening.